and tutoring. And congratulations on your success in CXC chemistry. And believe it or not, chemistry is it's indeed one of the harder sciences. It's actually the most difficult science compared to biology and physics. And that's because chemistry, it doesn't really have topics which are not related. The topics tend to be interrelated to each other. And so if it is that you have a deficiency in one area, it tends to affect you in many other topics to come. And that's the challenge with chemistry. That's why it's one of the more difficult ones. But congratulations for having been successful in CXC chemistry and wanting to pursue CAPE chemistry. So CAPE Unit 1 chemistry, it's not so much about it being difficult. I find that once you are prepared adequately, you are fine. You are able to function. One of the challenges I must say with the CAPE Unit 1 chemistry, though, is the length of the syllabus. This has been a syllabus that us teachers have been complaining about for years, asking them to see if they could cut down any of the topics because it's almost usually very difficult for us to finish the syllabus. And then the challenge with the Unit 1 chemistry syllabus is that not only is it a long syllabus, but then all the modules are complex. So we cannot really speed through any module. And it really is a very daunting syllabus. So because of that, you have to hit the ground running from day one with the chemistry. You can't be complacent and you have time. In fact, a lot of schools, they struggle so much to complete the Unit 1 chemistry syllabus that the last module 3, they don't get to teach it at all. Module 3 is just given as projects. You're broken up into groups, and each group is given a project to present a topic. And so the actual time and effort and energy that is spent on module 1 and module 2, module 3 usually doesn't get that time and effort. And the challenge with that is that in CAPE, all 3 modules are tested equally and they are weighted equally. And so your best chance of doing well is when you are actually prepared adequately for each module. So already this CAPE Unit 1 chemistry has that challenge of actually getting to complete the entire syllabus on time because it is such a lengthy syllabus. So chemistry is a branch of science concerned with the properties and the interactions of substances of which matter is composed. And the CAPE chemistry syllabus provides the specific knowledge base, the skills and the attitudes associated with advanced study of the subject. It is structured to ensure that students become aware of their moral, social, and ethical responsibilities, as well as the benefits to be derived from the practical application of scientific knowledge. Completion of the course of study outlined in the syllabus will enable persons to apply chemical principles to societal concerns such as birth control, communicable diseases, environmental pollution, global warming, and depletion of natural resources. So chemistry is designed for you to see chemistry on a much grander scale, a much wider scale than you would have thought of it before. That's to think of it as doing some experiments in a lab. Instead, CAPE is saying to you, no, it is to arm you to understand your social and ethical responsibility to your environment. And so you're going deeper in the study of matter so that eventually you learn its properties and how to manipulate it in order to enhance your environment. So I want you to look at this clip, looking at the importance of studying chemistry.
The world is currently facing some major challenges. Protecting the environment, developing sustainable energy, maintaining public health, and securing food and water supplies. Chemistry is the central science, the science concerned with all physical matter. We need creative chemists to find solutions.
Take climate change, the biggest challenge to human and ecological survival. Chemists strive to gain the knowledge needed to protect our planet. They observe the subtle changes in the environment, like ocean acidification, atmospheric pollution, and the buildup of marine plastics. Chemists at the University of Plymouth are at the forefront of research in this area, informing policymakers on how to protect our futures. They are not just in the lab, they are found working in extreme environments across the Earth, from the tropics to the remote deep oceans and the frozen polar regions. We know that sustainable supplies of energy are needed to replace our reliance on fossil fuels. Chemists at Plymouth create chemical models to innovate industrial processes. They work with nuclear reactors and develop catalysts that can recycle waste into new materials and energy. Chemists collaborate with industry to help businesses improve their operations on a local and global scale.
At Plymouth, I'm working with a team that care about these issues. I'm learning the hands-on techniques that industry and employers seek. I want a degree and a career that support change. I believe that together we are the innovators of the future. Find out more about our course.
All right, so basically what we are getting from this video, guys, good afternoon, Cameron. What we're getting from this video is basically what CAPE says they wanted you to become. They wanted to arm a group of scientists with the relevant foundation that you can go on to become the scientist that we were seeing in the video, that you can actually be a part of the team that can create sustainable alternatives to the future. So some of the things they mentioned, and maybe you never saw chemistry in that light. You may have just saw chemistry as something confined to the lab. They were showing you that the chemists were out in the oceans studying the acidification of the ocean. And they were working with industries to create solutions for them. They are trying to get better catalysts to some manufacturing processes so that less waste materials can be made. So chemistry, because remember, I wanted to understand that chemistry is the study of matter, of the properties of matter. And once you learn the properties of matter, because matter encompasses everything around us, liquid, solid, gas. If you understand the properties of matter, then you are able to manipulate it and be able to create better solutions from that knowledge. And right now, as it is in this world, one of the greatest problems we have that we need a solution for, that we need sustainable energy. We need sustainable energy. All right, so let's continue. So the Unit 1 chemistry syllabus for persons who are just joining, we were indicating that it's one of the more challenging syllabi to complete. And that's because each of the modules have multiple topics, and each topic has its own set of calculations, its own set of complex calculations. So by the time you have to learn the complex calculations for each topic in each module, you find that we spend the entire year, and we really only, most times, schools just get to teach module 1 and module 2. And module 3 is so challenging to complete. So basically, you're just divided into groups and given group work, group projects to present. But module 3 doesn't have calculations, but it is still fairly complex. It's more descriptive, but it's more complex. It's complex descriptions. So we end up having a Unit 1 chemistry ends up being a challenge because of that. The length of the syllabus and the complexity of each topic in the syllabus. So you end up having to learn multiple different calculations. So for you to really do well at Unit 1 chemistry, there is no alternative you have but to practice and get feedback on your work. So at Extra Time for our Unit 1 chemistry program, it is mandatory that whenever we're doing a topic or every topic, we have to actually demonstrate to you how to arrive at the solution for a problem. And after it has been demonstrated to you, then it was asked that you do a question or do something similar to what was demonstrated to you, so that you get to actually do it yourself and apply and see what steps you are missing. Once you are able to successfully do it yourself and we have verified that, then the next thing we do is show you how to do a question, a past paper with that information. And then once you are shown, then we give you a past paper to do and then give you feedback. So this chemistry requires that dance between you being given information, you absorbing it, you applying it, and we check what you have absorbed, and we keep that loop going. So it's not one of those subjects that you can just sit in a class passively and learn. It's not going to work out for this Unit 1 chemistry. So there are 3 modules, module 1, 2, and 3. In Module 1 now, the purpose of Module 1 is to get the fundamentals in chemistry. You have to understand that theories in chemistry are subject to change. Understand the theory of atoms, where it was used to construct and explain the behavior of matter and its impact in nuclear chemistry. Understand the development of the periodic table for the classification of elements. Appreciate that the forces of attraction between particles influence the properties and behavior of matter, and understand the mole concept. So look at that's 5 topics already. We have understanding redox chemistry. Then we have to understand equilibrium concepts, understand the kinetic theory, understand changes, energy changes, and be able to perform calculations. So the first module in Unit 1 chemistry has 6 topics. And for persons who are just joining, as I explained, this is usually the more difficult, this is usually the most difficult part of the syllabus to complete. The most difficult subject to actually get the syllabus completed. Because in Module 1, these 6 topics, complex. Atomic structure, you're going to go to a much deeper level than you did in CXC. You're going to go to, well, you had learned in CXC about shells and electrons orbiting on shells. You're going to be going to a much deeper level to realize that there are no shells in the atom. There are energy levels, but there are no shells. So we're going to have to teach this new concept to you and how the periodic table was developed. You're going to learn about electronic configuration of atoms. You're going to relearn it, because you learned about shells in CXC, that you could have 2 electrons on the first shell, 8 on the second shell, 8 on the third. You're going to see now that if the atom doesn't have shells, it has energy levels. You're going to have to learn now how to describe the atom in terms of energy levels and how to draw them. So this is going to be new principles for you in topic 1. The second topic, forces of attraction, is a bit more familiar. We'll look at ionic bonding, covalent bonding. But again, we're going into something that you never explored in CXE, which is to learn about van der Waals forces, types of van der Waals forces, how they are formed, how they're broken. So also some complex concepts here. Then we get to mole concept. Mole concept you did do in CXE, so this is usually very similar. A lot of schools actually start off with that because it's similar to what you did in CXE. But again, there are aspects at the CAPE level that you never had ventured in for CXE. Then we have redox chemistry or redox reactions. Similar to the CXE level, except more detail. Kinetic theory of gases. This is the topic that starts off complex calculations. How to calculate the volume or pressure or number of mole of gases. So this is where the calculation aspect starts, and it continues to energetics with another set of calculations. And so, as I said, the challenge with the Unit 1 chemistry, why you really have to be on top of things, is that each of these topics have complex calculations. So kinetic theory has at least 3 or 4 set of calculations that you have to learn specific to kinetic theory of gases. And you have to know what calculation to do when, right? So you're learning it, and then you have to when you get a question, you have to identify, okay, this calculation is required now. And that's one topic. Energetics also has about 4 or 5 different types of calculations. Again, you have to know which situation requires which calculation. So I had this video here just to show you one application of one of these first topics in Module 1, atomic structure and periodic table. Let me just show it to you quickly.
What have the Hulk and Spider-Man got in common? They both gained their superpowers because of radiation. Well, in films and comics at least. In real life, radiation has never given anyone superpowers. But when used carefully, radiation does have many uses, which we're going to look at in this video. Remember, the nucleus is found at the centre of all atoms. Some nuclei are unstable and may emit alpha particles, beta particles, or neutrons, and electromagnetic radiation as gamma rays. Watch this video to understand exactly what these types of radiations are. Gamma radiation can be used in radiotherapy for the treatment of cancer, Gamma radiation is directed at the area of the body affected by cancer. At high doses, radiation kills cancer cells or slows down their growth by damaging their DNA. These dead cancer cells are broken down and removed by the body. Radiotherapy doesn't work straight away. The cancer cells can take up to a few months to die and be removed by the body. Radiotherapy can also be used to destroy other tissues in the body that are not useful. For example, radiotherapy is often used in the treatment of overactive thyroid glands. If the thyroid gland produces too much thyroxine, it can result in heart palpitations.
All right, so guys, I was just showing you this as a prelude to some of the applications of studying atomic structure. We will learn extensively about radiotherapy or radioactivity, and one of the applications is actually in the treatment of cancer. All right, so we're going to learn about the unstable nuclei that releases radioactivity, and we'll be able to also predict what elements we will form after we have emitted radioactivity. So we're going to learn about that in module 1 under that first topic. Then under forces of attraction, which is the second topic in module 1, here's an application video for you.
Electrons are constantly moving around. In a given instance, electrons can be more dense in an area, causing temporary dipoles. These dipoles can induce dipoles into neighboring atoms. The opposite charges cause an attractive force known as the London dispersion force.
So guys, this is one of the new aspects that you're going to be introduced to in the forces of attraction. You're going to learn about van der Waals forces, things that you were taught in CXC that, oh, these are weak forces of attraction, and we kind of ignored them. Now you're going to learn them in detail to understand how they form, and sometimes they form because of how the electrons rotate around the nucleus. For example, if most of the electrons are on one side, it can create polarity or a dipole. So we're going to learn about that under forces of attraction. Kinetic theory, unfortunately, this video is not working, but it's going to deal with gases. So we can predict, it allows us to predict the pressure that a gas will exhibit or the volume that a gas will have if we're given certain data. So we'll learn about that. In module 2 now, which is looking at kinetics and equilibria, then we will learn about the concepts associated with reaction rates and the concepts of chemical equilibrium, and appreciate that principles of kinetics and equilibria can be applied to industrial and biological processes. So we have 6 topics here in module 2. And remember that I had indicated that from module 1, the last 2 topics were heavily calculation based. So more concept we know is calculation based. These 3 are descriptive, so not really much calculations, but 3 out of the 6 topics in module 1, calculation based. So we have more concept calculations. We have calculations associated with kinetic theory, at least 4 specific calculations. Energetics also, which looks at the energy changes in reaction, also has its own 5 or 6 calculations, and they are very specific calculations. So by the time we end with module 1, we would have already been learning so much calculations, guys. And I'm saying if you miss a step, you're going to have a problem. Because if you were not following with each calculation and kinetic theory and when we use it and how it is done, you're going to be flustered. And that's why I said to you, Unit 1, chemistry is not a subject you can swat, because you can't swat calculations. And it is heavily calculation based. So you have to make sure that you're keeping up, you're following. Whenever you're taught a calculation, that you do one for yourself, learn how to use the scientific calculator accurately. So you have to make sure you have your scientific calculators by the time you get to more concept and know how to use it to get the answers. So a lot of those skills are going to be important. Then when you get to module 2 now, you still have a lot more calculations to learn. So right here, rates of reactions has at least 5 sets of calculations for itself. Principles of equilibrium is descriptive based and has calculations. Acid-base equilibrium has calculations. So does buffers and pH. So does solubility product, and so does regular equilibrium. So all of these module 2 topics, heavily calculation based. And I'm talking about, as I said, at least 5 specific calculations. And I mean, these calculations are multi-stepped calculations. So each one of them might have like 5 steps. 6 topics doing that, in addition to the 3 topics from module 1. So you're looking at probably over 40 different type of calculations you have to learn for unit 1 chemistry, module 1 and 2. All right. So that's why I said to you, it's one of the most challenging syllabi for us to finish it. Most challenging syllabus to finish is the unit 1, because there's no way to speed through it. There's no way to give you passive learning, because if you are giving it passively, you're going to struggle with the calculations. Where if it's mostly descriptive and reading, you can manage that. But these parts, you have to be shown, you have to be taught, you have to do examples for yourself. And then most importantly, you have to do a question on it. So if you have learned a calculation, for example, in rates of reaction, you need to do a question that requires you to use that calculation. And so you're comfortable that you can do it adequately. So you have to be doing simulations in Unit 1 chemistry to be successful at it. This is just one aspect of rate of reaction, a video here I want you to see.
Temperature is a measure of the average kinetic energy of the particles in a system. That is shown on the Maxwell-Boltzmann distribution curve, because when we say that a system has a certain temperature, say T1, what this curve tells us is that the particles' energies are distributed across the entire spectrum, meaning that particles range in energy from 0 to a theoretically infinite value. In much the same way as when the average for a class test is 60%, that does not mean that every single person in the class got 60%. It means that the marks ranged from 0 to the maximum for that test, with the average being 60. So what this curve shows us is that a particle can have a very, very small value of energy, but it can also theoretically have a very, very large value for its kinetic energy. But the average energy is centered around T1. Now, the reason why this is important is because in rates of reaction, we say that there's a certain activation energy that is required in order for a reaction to take place. Now, the way we would read this graph is by looking at it and seeing that only the particles that have more energy than that required activation energy are able to take part in that reaction, which in this case is a very small fraction. Now, there are 2 ways in which we can increase the number of...
All right, so guys, this is not going to mean much to you just yet, but I'm just showing it to you that when you actually get there, it doesn't seem so completely foreign to you. But this is one of the things on the rates of reaction, apart from the calculations that I told you about, the 5 calculations. This is another thing we are going to describe graphs, which show us how it is that when we increase the temperature, the rate goes up. We have to explain it using this Maxwell-Boltzmann distribution graph. And it also helps us to explain how catalysts increase the rate. So as I said, the Unit 1 chemistry is one of those subjects that will filter students. Students which are disciplined, students which are analytically minded versus persons who are just swatting. You could swat your way all the way up to here, but this subject is going to stop you. It's going to phase you out. If you did not develop the discipline and the skills to properly study, properly acquire information, it's going to be a challenge, because it is a mixture of everything: description, calculations, analysis of graphs, tables. All of it is inside of this Unit 1 chemistry. So as I said, my suggestion is be alert from day 1. Just start participating from day 1, right? You're also going to learn about buffers and pH. This video was about the buffer system we have in the blood.
Let's learn about the bicarbonate buffer system. Blood is maintained at a narrow range of pH, which is between 7.35 and 7.45. Serious problems result from blood that is too acidic or alkaline. Abnormal pH can lead to coma and death. One of the ways by which the body maintains the blood pH is through buffers. The most important buffer in the blood is the bicarbonate ion buffer. Before we see how it works, let's review a little bit about acids and bases. Acids are molecules that tend to give up hydrogen ions. For example, hydrochloric acid dissociates into hydrogen ions and chloride ions. As a solution's hydrogen ion concentration increases, its pH goes down, making the solution more acidic. Bases tend to combine with hydrogen ions, neutralizing them to form water. For example, sodium hydroxide dissociates into sodium and hydroxyl groups. The hydroxyl ion combines with the hydrogen ion, neutralizing it. As a solution's hydrogen ion concentration decreases, its pH goes up, making the solution more alkaline. If there are too many hydrogen ions, or an increase in hydrogen ion concentration in the blood, the bicarbonate ion combines with the hydrogen ion to form carbonic acid.
All right. So guys, we're going to explore this topic of the buffer some more, but this was just an introduction to show you that in our blood, we do have ions that are able to absorb excess hydroxide. If we have excess hydroxide ions in our blood, we have hydrogen ions to react with those hydroxide ions. And if we have excess hydroxide ions, we have acid in our blood to react with them. And we're going to learn to do calculations of buffers as well. So then we have redox equilibrium. This is when we're going to learn how to put redox equations together to generate electricity. So we have to study redox equations before, which we would study those in module 1, and then we'll come back to it again in module 2, where we'll learn how to combine those equations to generate electricity and how to calculate or determine the magnitude of electricity that we're going to form based on the reactions we chose. Again, specific calculations associated with this. And one of the applications of this topic is how batteries work. I'm going to skip that video though. So then we come to module 3, and as I said, most times by the time we get through all the calculations for the last 12 topics in module 1 and 2, that usually most schools, that's what all they're able to do. But then there's this other module there. But the good thing about this module is that it is descriptive. It has no calculations whatsoever. So, and I think that is why the schools get through it fast by just assigning projects to each group of students and have you present the projects to each other, because it's descriptive and you can technically read through it and understand. So here in module 3, we use fundamental concepts to rationalize the physical and chemical properties of elements and their compounds, and appreciate that the properties of elements are related to their compounds and their uses, and understand the principles underlying the identification of anions and cations. All right, so here we have 6 topics again in module 3. We are going to learn about period 3, which is the elements in the 3rd row of the periodic table, which includes sodium, potassium, magnesium, silicon, phosphorus, sulfur, chlorine, and argon. So all the elements in the 3rd row of the periodic table, we're going to learn about them, and we're going to learn about the trends that occur as we move from sodium to argon in period 3. We're going to then learn about the trends that occur in group 2. So that group 2 would be beryllium, magnesium, calcium, barium, strontium. So we're going to learn the trends that occur as we go down group 2. Then we also will learn the trends that occur as we go down group 4 elements. Group 4 includes carbon, germanium, silicon, tin, and lead. We're also going to learn about the trends that occur as we go down group 7. And group 7 includes fluorine, chlorine, bromine, iodine, and astatine. Then we have another row, we'll have another period we're going to learn about, which will be the 1st row transition metals. So we're going to learn from scandium all the way over to copper. So we have 3 groups of the periodic table that we're going to learn in detail about, and 2 periods that we're going to learn about. And finally, then there's the identification of cations and ions. So what are the tests that you do in the lab if you want to identify what cation you have in a sample and what anion you have in a sample? So we have these 6 topics. They are descriptive, but they have specific trends that you have to know. So you tend to have graphs to interpret. When you look at different properties as you go across a period or down a group, you have to explain like changes in melting point and changes in boiling point and changes in electrical conductivity. You have to be able to explain why these change as you go down the group or across the period. So that's module 3 for you. This one is a video on group 4 elements. Let me just show you this one.
Hi, student. we meet again today. Today, we will learn about
Sorry.
Hi student, we meet again today. Today, we will learn about advantages and disadvantages of ceramics. First of all, let's discuss about advantages of ceramics materials. It includes harder than conventional structure metals, low coefficient of friction, extremely high melting point, corrosion resistance, inexpensive, easily available, low density and glazed ceramic does not stain. While the disadvantages of ceramics materials include dimensional tolerance is difficult to control during processing, weak in tension, can crack when hit with heavy items and poor shock resistance.
So you will learn about the group 4 elements, such as I said, lead, tin, germanium, etc. And this was just showing you some of the properties that you'll see in group 4. Then we're also going to learn about first row transition metals.
Welcome to Moo Math and Science. In this video, I'd like to talk about the transition elements. The transition elements are elements found in groups 3 through 12. Technically, they are an element that has an incomplete D subshell. Here's the list of the transition metals with their number of valence electrons. The transition metals are metallic elements that help serve as a bridge between the two sides of the table. The lanthanides and the actinides at the bottom of the table are sometimes known as the inner transition metals because they have atomic numbers that fall between the first and second elements in the last two rows of the transition metals. Transition metals tend to be very hard. They look shiny and metallic. Most transition metals are grayish or white, but gold and copper have other colors that are not seen by any other elements on the periodic table. The transition metals as a group have high melting points, except for mercury, and they also have high boiling points. Although transition metals are reactive, they are not as reactive as the alkali metal groups. Most transition metals have 2 electrons in their outer shell, but some have 1 electron, and palladium has 18. But they all have an incomplete D subshell. So there we go, the transition metals.
All right, so you see that these metals have unique features, unique properties.
Thanks for watching, and Moo Math uploads a new math.
As opposed to the regular group 2 metals or group 3 metals. Transition metals are tougher metals. They are better able to conduct electricity. They are better able to resist corrosion. They have colored compounds, and we're going to learn the chemistry as to why they're able to do all of this. And then there's the identification of cations and anions, which you did do in CXC. So this is basically a repeat of it, plus more. It's a bit more advanced. How to identify the anions and how to identify the cations. So guys, if we start off this weekend to the end of April, it's usually 32 weeks between now and the end of April when you should be finished with the preparation. And there are usually 6 weeks where you don't have class: December, Heroes Week, and Easter break. So that leaves you with like 26 teaching weeks. Cape Chemistry, Unit 1 Chemistry, I must say, takes at least about 38 weeks to complete. So because of this now, we end up having this challenge. We have to schedule extra sessions for Unit 1 Chemistry. Like even in the December break, before you go off the December break, we sometimes, at the center where we have extra time tutoring, we have to put in some extra sessions when you're going after holidays and so on, because it's just not possible to do it in the 26 weeks because it's not something you can SWAT. So Unit 1 Chemistry always requires extra sessions. So be prepared for that. So with 38 weeks required and you have 26 teaching weeks, you can definitely see the problem. So be prepared to be doing extra sessions in December or in January or in Easter. Unit 1 Chemistry requires that, especially if you're going to be taught all the topics and not be given a shortcut as just getting a project or something. Now, in terms of your assessment, The assessment, you're graded equally for paper 1 and paper 2. So paper 1 is worth 40% of your grade and paper 2 is worth 40%. So there is no distinction between paper 2 and paper 1 in CAPE. The same level of difficulty for your paper 1 multiple choice questions is the same level of difficulty for paper 2. So there's no swatting. There is no waiting until the end and swatting for paper 1. No, the questions are complicated. They still require multiple steps of calculation to get the answer. And because it is a multiple choice, they'll put many answers that are seemingly close to each other, which makes it even more difficult for you. So your level of preparation has to be equal for paper 1 and paper 2. Paper 1 has 45 questions, 15 questions from each module. And paper 2 has 3 compulsory questions, 1 from each module. And they also test your knowledge of experimental skills, 1 from each module. Each question is worth 15 marks. That's section A. So section B, there are 3 compulsory essay questions, 1 from each module, and each is worth 15 marks. All right. So the first section, section A, with the 3 questions, it is testing your knowledge of experimental skills from each module. And in section B now is essay questions from each module. So you're basically getting in paper 2, 2 questions from each module. 1 is heavily experimentally based. And then you have your internal assessment, which will be your practical exercises, which is worth up to 20% of your grade. This is telling you some more about paper 1, having 45 multiple choice questions, 15 from each module, and all questions are compulsory. And knowledge of the entire unit is expected because it's going to assess your breadth of the topic. The paper is worth 45 marks and will be weighted to 90 marks. Question may be presented using using diagrams, data, graphs, prose, or other stimulus material. Paper 2, which lasts for 2 hours, 30 minutes, composed of 3 questions, one from each module, and they're compulsory. And they test knowledge and comprehension, use of knowledge, and experimental skills. And there is knowledge of entire units is expected. The paper will be worth 90 marks, 30 marks per question, and distributed across the sub-parts. Questions may be presented in structured essay format, and the questions will test the skills of knowledge comprehension, use of knowledge, and experimental skills, and the answers are to be written in the answer booklet. Now, whereas they don't, CAPE doesn't specify how many labs you have to do. You have to do at least 2 labs on each of these skills. Question, do you need to draw diagrams for paper 2? Yes. But they will come out they will explicitly ask you for the diagram in chemistry. So they will ask, not like in biology where they won't necessarily ask you for it, but it's expected. Chemistry will tell you when they want the diagram. And there will be specific diagrams that you're going to learn for each topic that you just need to practice and reproduce. But the major thing in the Unit 1 chemistry is more the calculations and the definitions as well. But the calculations will get you if you weren't practicing them. And so for the labs now, you want to do at least 2 labs on observation, recording and reporting, manipulation and measurement, analysis and interpretation, planning and designing. So you want to do at least a minimum of 8, but most schools are going to do more than 8. You just have to make sure that each skill was assessed at least twice for each module, each unit, sorry. So as it is for your grade, you have your multiple choice, as we said, 15 questions from each module. Paper 2 has structured and essay questions. So the structured questions come first, 1 from each module, and they are experimental based. And then the essay questions come afterwards. So that's how you end up having 30 points per module. And then they weight it. But at the end of the day, paper 2 is worth half of your grade and paper 1 is worth half of your grade. And the labs are worth 20% of your grade. And the labs are also testing the modules equally. So you need to the teacher has to make sure that the labs that are chosen are from module 1, 2, and 3, and assessing the 4 skills that CAPE wants. So guys, to make it in the Unit 1 chemistry, you can't go less than 3 hours per week. And if for no other subject, you have to do past papers, well, Unit 1 chemistry is a must. You have to practice, as I said. You have to have out your scientific calculators for each class. You have to follow each calculation because remember, each topic has at least 5 unique calculations for that topic. And each calculation has at least 4 or 5 steps. So it's a lot to remember. The only way to really remember it is to do it. Do it repeatedly, and then it will be entrenched in your system. And you must be following as we're doing it. So as you're shown, make sure you can reproduce one. Once you follow that system, and once you have done the calculations and you're comfortable, you apply it to a past paper, you'll be fine. So Unit 1 chemistry is one of those that force you to be disciplined if you want to have any chance of doing well. You also want to score optimally in your labs. You want to get at least 20%. So the grading system for CAPE goes all the way down to 7, but of course, beyond a 5 is considered to be a failure. If you get a 6, it suggests that you have a limited grasp of the principles and concepts. Grade 7 is very limited. 5 shows acceptable. Grade 4 is satisfactory. Grade 3 is good. Grade 2 is very good. And grade 1 is an excellent grasp of the principles. So, all right, program or our desire is for you to be scoring a grade 1 or 2. Grade 3 is good. And beyond grade 3, for most, you will be accepted for programs if you actually get up to grade 5. But to be competitive for scholarships and for those programs that have limited spots which are government sponsored, you definitely want to be going for a grade 1. So they actually have a point system in a lot of these competitive programs, and you're given more points when you get a grade 1, less points when you get a grade 2, not to mention a grade 3. So guys, at this level, aim for the top, mastery, all right? And when you're the grade slip will show the profile as follows, and it's based on the 3 modules. So there's module 1, which is fundamentals in chemistry, module 2, which is kinetics and equilibria, and module 3, which is chemistry of the elements. So your aim is to get an A in all 3 modules, and you will secure that 1. Any module you fall down in, which I said usually, well, module 2 is usually the most difficult module, and module 3 ends up not being taught in many schools. So that usually forms a struggle. Most schools will get through module 1 and get through module 2 to an extent, but module 3 usually suffers. And then even when you get through module 2, because there are so many calculations in there, if you didn't apply yourself, you have trouble. So this is one of those subjects that you cannot underestimate. You have to go full force at it if your intention is to get a grade 1. Make sure you do have your own personal copy of the syllabus and tick off the objectives as you learn them each week. Read ahead of your experiments. Once you know what objective the experiment is coming on, research it. Go ahead and research it. And if possible, watch the lab on YouTube before you actually do it physically, because you'll understand it better and it will reinforce the concepts better in your head. So those are the things I'd like to know about CAPE Unit 1 Chemistry. Do you have any questions? Any questions? All right, guys, thank you so much for attending. All right. And as I said, once you start, well, at Extra Time, we're going to get started next week, Saturday, with the Unit 1 Chemistry. Once you get started, you just attack it viciously, ferociously. Just keep at it, right? That's how Unit 1 Chemistry is defeated. All right. Thank you so much for attending, and all the best in your studies and your preparation, and congratulations on your CXC passes, guys. Okay. Enjoy the rest of your day. Bye, guys.